What if we could build a perfect real-time map of our planet? I mean, one that could see right through clouds and even help us design a better future. Well, today we're diving into AlphaEarth, a truly revolutionary AI from Google DeepMind that's trying to do exactly that. We live in this age of just incredible observation. We have satellites constantly beaming down terabytes of data. But here's the paradox, right? With all this information flooding in, why is it still so unbelievably hard to get a single, clear, up-to-the-minute picture of Earth? Well, the short answer is we're basically drowning in data. It's like trying to build one giant puzzle, but every single piece comes from a different box. You've got optical images, but oops, they're blocked by clouds. You have radar that sees through clouds, but it's capturing totally different information. Then you throw in climate models, 3D elevation maps, all with different formats, different schedules. For scientists, trying to stitch this all together has been a monumental, almost impossible task.
Now, this is the exact problem Google DeepMind decided to tackle with AlphaEarth, and their solution is pretty brilliant. Think of it less like a typical AI and more like a virtual satellite. It's a foundational model designed to take in all that chaos and fuse it into one coherent, intelligent picture of our world.
So how in the world does it do that? The core technology is something called an embedding field. Okay, so for every 10 by 10 meter patch of land on Earth, think about that, the entire planet, AlphaEarth creates a unique digital fingerprint. And this isn't just a picture, it's a super dense summary of everything: vegetation, soil moisture, changes over time, all of it, compressed into a single numerical code. And this is a little peek under the hood. Now, don't worry about all the complex boxes and arrows here. The main thing to see is on the left, you have all that raw, messy data coming in from multiple sources like Sentinel and Landsat. It all flows through the sophisticated architecture in the middle, and then out the other side comes that single, unified understanding. It actually learns the relationships between all these different data types, which is how it can do incredible things like filling in the gaps where clouds used to be. And the results of this approach, they're kind of staggering. First up, efficiency. That embedding field is so packed with information that it needs 16 times less storage than the next best methods. I mean, just think about what that means for a second. Global scale analysis that used to be only for supercomputers is suddenly so much more accessible. And here's the kicker. It's not just more efficient, it's way more accurate. By intelligently fusing all those data sources, AlphaEarth slashes mapping errors by an average of 24% compared to other top systems. So you're not just getting a smaller model, you're getting a better one. So what does this new vision of Earth actually look like? Well, it looks like this. And I want to be crystal clear. You are not looking at a photograph. This is a visualization of that 2023 embedding field. Every single color represents a rich, multidimensional fingerprint of the environment. You can literally see huge climate patterns and ecosystem boundaries that are totally invisible in a normal satellite image. It's a fundamentally new way of looking at our planet. A new lens like this is absolutely incredible. But the real question is, what can we do with it? And that brings us to the first of two major revolutions this technology is kicking off, completely changing how we manage our climate and our food supply. Okay, let's take a classic real-world headache. The Amazon rainforest is critical for the planet, right? But it's often covered by clouds for months on end. This makes it almost impossible for organizations to track illegal deforestation as it's actually happening. But with AlphaEarth, which can effectively see through those clouds by using radar data, partners like Map Biomas in Brazil can finally track this stuff in near real time. As its founder, Tasso Azevedo, puts it, they can now make maps that are more accurate, more precise, and faster. This isn't some promise for the future, this is happening right now. And this is where the story gets really, really exciting. It lets us move beyond just monitoring problems. We can actually shift from just predicting the future to actively designing a better one. We can simulate the global effects of climate policies, find the absolute best places to build solar farms, and even guide farmers to the exact crops that will give them the biggest harvest while using the least amount of water. And just look at the list of early adopters. It shows you how versatile this thing is. Over 50 organizations are already putting AlphaEarth to work. We're talking everyone from the UN's Food and Agriculture Organization to top universities like Harvard and Stanford, all using it to tackle some of our biggest environmental challenges. So that's the impact on the natural world. But what about our world, the man-made one? Well, the second revolution shows how this same planetary blueprint can be used to completely rethink our cities and understand our economy. And the applications here are just so broad. For city planners, it means being able to see which neighborhoods are most at risk from floods or heat waves 30 years from now. For the finance and insurance industries, it's about accurately pricing climate risk not just for a country, but down to the square meter. And for conservationists, it means figuring out exactly which ecosystems are the most critical to protect.
So what's the big takeaway here? It's that we gain this ability to build more resilient cities, to visualize the complex, almost invisible flows of the global economy, and to make way smarter decisions about protecting biodiversity. For the first time, we can finally see the entire system working together.
But, having a tool this powerful forces us to stop and confront some pretty profound questions. This isn't just about what we can build anymore. It's about what we should build. It's about the future we choose to create.
And the next big step is already right around the corner, connecting this planetary model with large language models like Gemini. Just imagine being able to ask, in plain English, hey, show me all the regions in Southeast Asia where mangrove forests are at risk and crop yields are going down, and getting an instant, data-backed map. That's where all of this is headed. But of course, this kind of power is a classic double-edged sword. On one hand, making this data open could empower researchers everywhere, giving us a shared blueprint to solve global problems. But on the other hand, it concentrates immense analytical power inside private infrastructure. It brings up critical questions about data transparency, and it carries the very real risk of algorithmic bias if it's not managed carefully. And this is exactly why the scientific community is calling for a balanced approach. As one expert noted, the model is incredibly powerful, but its outputs absolutely must be independently validated. At the end of the day, the responsibility is on the researchers and the users to really scrutinize the results and understand its limits. Which brings us right to the final critical question. For the very first time, we have a tool that gives us the power to not just map our planet, but to actually simulate and design its future. This technology doesn't give us the answers, it gives us a much, much better way of asking questions. So the only one left for us is, what future will we choose to design?
And that's our look at AlphaEarth. Thanks so much for joining me for this explainer.